So after a delay of 0.13 second in the AV node and the bundle of His, this impulse enters the interventricular septum. So after this impulse passes through the interventricular septum through both the left and right bundle branches. So the whole septum is depolarized, and then this impulse actually travels towards the apex of the heart. So this is the apex, okay? So it travels towards the apex, and then the impulse travels along the endocardial surfaces on both sides, left and right ventricles, okay? The endocardial surfaces of the ventricles are depolarized. This cardiac impulse spreads through the inner surfaces of the ventricles, the endocardial surfaces of the ventricles, okay? And then after this impulse passes from the endocardial surfaces towards the epicardial surfaces. So let me draw the arrows so that you can understand what is the direction of transmission of this impulse. So let me tell you that after septal depolarization, okay, this impulse actually travels along these endocardial surfaces, along these endocardial surfaces, okay? When endocardial surfaces are depolarized, okay, on both sides, then what happens that this impulse passes from the endocardial surfaces towards the epicardial surfaces, okay, towards the AP in this way, okay, from endocardial surfaces towards the epicardial surfaces in this fashion. So as you can see, if you look at I have drawn the arrows. So as you can see that after delay in the AV node and the bundle of phase, the first part of the ventricle that is depolarized is its septum, okay? So this septum is depolarized, this impulse reaches the apex, and from the apex this impulse travels along the inner surfaces of the ventricles, endocardial surfaces, okay? And then this impulse passes from the endocardial surfaces to the epicardial surfaces, and it passes through the whole thickness of the ventricular muscles. So both the ventricles, so in this diagram on the right side you can say both the ventricles are purple, so that means that both the ventricles are fully now depolarized. But you see, this transmission of impulse through the ventricles takes place through this Purkinje system, okay, through this Purkinje system. And remember that the Purkinje system has very large sized fibers, the diameter even larger than the the ventricular muscle fibers. The fibers in the Purkinje system have a very large diameters, okay? So because of that, what happens that the resistance to flow of ions is very less in the Purkinje fibers, number one. And secondly, the number of gap junctions is much higher than any other part of the heart, number of gap junctions. So because of these two reasons, the large diameters and more number of gap junctions, this impulse travels very fast. So it takes from this point, you see, from this, after it enters the septum, this impulse enters the septum. From this point up to this point, it takes about 0.03 second, 0.03 second, okay? And from endocardial surfaces to the epicardial surfaces, the impulse transmission takes about another point. I'm doing it with the mouse, so that's why I cannot write it properly, but another 0.03 second is taken up by the impulse to travel from epicardial to from endocardial to epicardial surface. So both the ventricles are completely depolarized within 0.06 seconds, 0.03 second by the impulse to go from this point, okay, to reach the to depolarize the inner surfaces of the heart, and then another 0.03 second is taken by the impulse to pass from the endocardial surfaces towards the epicardial. So both the ventricles are depolarized within 0.06 seconds, within 0.06, and this is because of the large diameters of the Purkinje fibers, his Purkinje system, and also more number of gap junctions in the Purkinje fibers, so which transmit this impulse at a very high velocity, and both the ventricles, they are depolarized in instantaneously, simultaneously, so that both the ventricles, they contract at the same time in unison, synchronously, thus pumping the blood.